Hello everybody, my name's Chris Ward and I'm one of the product managers for the controlled product business, and in this example it's going to be based around the SIMOCODE Pro unit and how to parameterize some of the functionality which is integrated into the unit. So this example is going to be solely based on the motor protection side of the SIMOCODE station. So if you haven't already built up a program already, please refer back to one of my previous videos which shows you how to set up a configuration from start to finish. There's a DOL one and there's also a reversing pair setup. So yeah, I mean, the motor protection functionality in the SIMOCODE station is a really good feature and function to get hold of and utilize, and I want to show you some of the features surrounding that today. So we'll jump straight into that now. So if you go into this left-hand column here, you can see I've already created a SIMOCODE station. If we drop that menu down, there's a host of different functions in here. I mean, to be able to gain access to what we want, we need to go into the parameters. And just so you can gain a bit more of a visualization of the screen, I'm going to close this window down slightly now, and also drop this menu down the diagnostics buffer at the bottom, so we get more of a screen capture of what it is we're actually looking at. So as you can see here, there's a number of different options down this left hand side. If we drop motor protection down, which is the one that we're going to be focusing on, we've got overload, unbalanced, stalled rotor and thermistor. So there's quite a comprehensive range of options there for your motor protection. If you access and parameterize them, and you get to decide how they react under specific conditions. So it gives you a really good overview of protection into if you are accessing all four options of these and utilizing them to the best of the SIMOCODE's ability. So let's just jump into overload and see what this function can do. So firstly, when you're setting the overload, it's always good to set the current rating. So you set the current to what it says on the nameplate. So what's the operational current of the motor? For this example, we'll assume that we've got a motor which is rated at 0.3 amps for the operational amperage. And then if you move on from that, you can see here there's a class rating, and there's quite a lot of options there for what you can set that class rating to. And just to give you a general rule of thumb, if you're setting it to class 5, it'll allow the motor to overheat for a specific time frame of up to 5 seconds, 7 seconds, 10, 15, and so on. You get the idea. So dependent on what you set this class rating to would be dependent on when the device trips out under thermal loading. For this example, we'll set it at class 5, so it should take roughly 5 seconds for the device to trip. Here below that, you've got here a response to that trip level. I mean, 9 times out of 10, in the case of an overload function, you're going to want the device to trip out, but there are a host of other options which you can choose from here. You can deactivate the overload if you wish. You could have it protected by an external device. You can send a signal via a PLC, or you can flag up a warning on a HMI screen which is fixed into the SIMOCODE system, or the normal case is that you can get the device just to trip out in the event of it breaching the 5-second startup. So the idea is that if you get to 5 seconds, the device will then trip out. Once the device has breached 5 seconds and the device has tripped out, you then get to decide on how long you want the cooling down period to be. The thermal model of the motor is quite important to this. I mean, you don't want the thermal model of the motor to be still at 80 to 90% before you initiate a start. So you'd want a nice cooling down period here, and as you can see, there's quite a vast range from 60 seconds up to over 6,000 seconds here. I mean, the general setting for this is 300. But you can set it down to 60 if you wish, if you feel like that's enough time for the motor to cool down. This option here, is pause time, and this doesn't really affect the device if it goes into trip. So in normal operating conditions of your motor, say for example the motor was starting to overheat slightly, and then you initiated a stop and it didn't trip out, what this would do is this pause time would allow the device to rest for a specific time frame, providing that it went under the threshold and it was suitably cooled and the thermal model of the motor was significantly lower. So the idea is you can set a time in here from, again, it's past 6,000 seconds under normal operating conditions without a trip for the device to cool down suitably before you initiate a start. In this next box here, you get to choose between what kind of a load it is, so single or three-phase. Typically, we use three-phase induction motors with the SIMOCODE system. 9 times out of 10, that's what it'll be, and it automatically selects that. Similar to some of the other options, there's a few different options here where you can have warnings to your overload as well. So you can say you could have a response to a pre-warning of going above 115% of the operational current, and you could decide how that reacts. So we could have a signal going to a PLC, or perhaps a warning showing up on the HMI screen. Typically, I favour using a warning which flashes up on the HMI to be able to do that. And also you can have a delay to a warning, and that's typically if your current's fluctuating. You might not want it to flag up for, say, you might give it a 1 second delay and give the chance, if you do have current which fluctuates quite regularly, up and down intermittent fluctuations, you might want to have a 1 second delay so you don't get any nuisance warning lights popping up. This next option here just gives you unbalanced protection. So the idea is you can give it a range from anywhere between 0 and 100% on the phase imbalance. So on your three phases, it will monitor any discrepancies between the three phases. So say for example, if you had a 50% discrepancy between each of the phases, you will have a problem with the motor and it is acting uncharacteristically, and that can have a detrimental impact on the motor's windings. So you want to know, you would want to know about that. So again, you can set that to anywhere between 0 to 100%, and then you can decide how it reacts to that. So you can have a signal, a warning, or a more serious trip to that. So again, you may get fluctuations, so I mean you might want to put a delay on that trip to 2 seconds. And then this last selection here is the stalled rotor protection on this selection. So you've got stalled rotor. Stalled rotor can be used for, say for example, if you've got a conveyor belt that's jammed and you get a pretty quick current rise there if you've got a jammed conveyor belt. And you can set that from anywhere between 0 and 1020 percent. So if you might want to set that to 800, you might want a response to that delay. You might want the delayed response to that, but also you want to decide how it reacts to that. And if you've got something as severe as an 800% current rise, the chances are you're going to want that device to trip and not warn under those conditions. So they're the three features which are in motor protection, but there's also another feature here which is called thermistor protection. So Siemens has what we call complete motor protection in the SIMOCODE station, meaning that you get complete visibility of your motor protection with overload protection and thermistor. So with the thermistor, you get to decide how you react to that trip level, whether you want to signal, warn, or trip. So what is the response to the trip level? Well, under normal circumstances, it'll be trip. And then if you've got, say, for example, a sensor fault, whether it's a short circuit or whether it's an open circuit, you can then decide how you want to react to that. So typically it's not critical to the application. If you've got a fault on a thermistor, you've still got the backup of the overload protection, provided that you don't have any issues with that. So you might want that to just warn out. So now we've configured the motor protection. We can now have a little look to see see that functionality, to see how it's actually worked, and to see if it's being configured correctly and it's acting accordingly through the simulation data. So we'll jump straight into that now. So in this next part, what we need to do is go into the online configuration. So go to commissioning, go online. Once this blue bar turns orange, we know we're in the correct window and the device is online. So to be able to do this, my device is connected up to a SIMOCODE station, and the objective is this, just to try and ensure that the thermistor is working correctly and also the overload protection. So if we go now and access the motor and turn it on, we should be able to see in the measured values section here, you can see how much current's being consumed. You can see the phase imbalance here. You can see the thermal model of the motor, the time to trip, and the cooling down period. So for example, if we was to have a little look in warnings, and we can see here, we can gain access to the thermistor short circuit and the open circuit faults. So that's if there was any faults on the device, you would get a warning light pop up on here. If the device on the thermistor was to trip, it'd go into fault. Similarly, if you had an overload condition as well, that would also go into fault. Also, imbalanced or stalled rotor, if they were breached, they would also go into fault. So if you're using the diagnostics buffer, which is integrated into the SIMOCODE station, these online features, it's a great way to gain an overview of what's going on with the system. So for this example, what we'll do is we'll toggle the thermistor now, and we should be able to see a trip. So let's have a little look at that. So if we turn the thermistor right the way up, as you can see now, the thermistor has gone to trip. So if we turn that right down now and press the test and reset button, that should clear off. As you can see, it has. And as you can see, what I've also done now is I've turned the thermistor pot down, and it's created a short circuit. And as you saw just then, this bar was yellow, so we know that there's a warning coming on when you have a short circuit protection. And then the next feature, just to have a little look at, would be the the thermal model of the motor in the event of an overload. So if we was to turn the current right the way up, you can see the thermal model of the motor now, it's starting to increase. When it gets to 100%, we know that the time to trip will be that will be the time to trip, and the motor will then cease, and then the cooling down period will start. As you can see now, it's set to 60 seconds and that clock's counting down. So you can acknowledge the fault in that time. You can press the test and the reset button to say, yes, I've acknowledged that there's been an overload condition, but you still have to wait to allow this thermal motor model to come down in temperature, so that you're not causing any further damage to the motor. So I hope you found the video useful, and if anybody has any suggestions on any videos they'd like to see more of, please feel free to leave a comment in the box below, and stay tuned for more videos to come. Thank you.